Hello dear students, let us see the unit commitment. So regarding unit commitment, in the previous classes, in the previous semester you have studied this unit commitment. So thoroughly we will study in this semester. Before going for unit commitment, we will see the difference between the unit commitment and economic dispatch. So economic dispatch you have studied very well in the previous semester. Economic dispatch is nothing but if n numbers of units are there, all the generator units are on in the position, that is the meeting the demand. All the generators are supplying the supply with the minimum cost, that is called as economic dispatch. So in the economic dispatch all the units will be on, then the units which are on all are working economically, means which gives the minimum cost. Okay, but unit commitment is not like that. Unit commitment is what? If n numbers of unit will be there during the peak hours and non-peak hours, then the powers required will not be the same. If whenever your power demand is low, you need to shut down some units which is not necessary. So or some during some peak hours you need to switch on the idle units, or which is kept off, that need to be on. Then choosing which unit should be on and which unit should be off. So the committing the unit for on condition and off condition is called as unit commitment. So these are the difference in the unit commitment as well as the economic dispatch. So before going for the unit commitment, we will see some assumptions need to be seen. So what are the assumptions here? The first assumption is made is the load is not affected by adding or removing units. So means your load is fixed. If you are adding your units and removing your units, your load will not be get any effect. The second one is the interchange will not vary. The net interchange will not vary when units are added and removed. When two areas are there, the net interchange will not vary by adding or removing the your units. The unit fuel cost are composed of starting cost and no load spinning cost as well as loading cost. Means a cost of one unit means it is including all the startup cost will be there, spinning reserve cost will be there, and loading cost will be there. All those things are includingly we are calling it as unit fuel cost. Some not only the cost of the fuel, it includes all these values. Then all the units running at any moment in time are always economic dispatch. This is one of the very important consideration is, whichever units are on, all the units are working in economic dispatch. Means what? Which gives the maximum beneficial output, means efficient output, means which is very lesser cost only it is working. Means all the on generators are working in economic dispatch condition only. So some of the issues to be considered when solved for the unit commitment problem is that those issues are, one first issue is hourly power demand for the next 24 hour. So what are the next 24 hours demand should be considered. Number of hours the unit already been running, the unit which is running, how much hours it is already running. Availability of the unit for a part or whole, the scheduling time. For the scheduling time, what are the availability, whether partly it is available or full time it is available. Change in the generation limits of the units during the commitment period. If any changes are taking place on the generator limits, then it should be known. Minimum uptime and downtime of the units. This is what, as I told you in the previous semester itself, if one generator is on means for particular time it should be on in condition only. Once it is off means for particular time period it should be off only. Those conditions are called as minimum uptime and minimum downtime, that should be known. The response rates of the units as a function of their output. The response rates of the units are the function of the output. And reserve capacity needed, what are the reserve capacity of the units, and constraints on thermal and hydro units. Whenever combination of hydro and thermal units are there, then constraints should be known. So we will see the simple enumeration, brute force. So how one unit commitment is working, I will give you one example. So by seeing this example only we will come to know how unit commitment is done. For the 2 units, very simple 2 units I am going to give you. You can see here, two generators are given with the cost function, a fuel cost function. First one is F1 is equal to 400 plus 6 Pg1 plus 0.004 Pg1 square dollars per hour. This is the fuel cost of the first generator. And second generator is given by 500 plus 6.4 Pg2 plus 0.002 Pg2 square dollars per hour. This is the second generator's fuel cost. So two generators limit is given 1100 megawatt lesser than or equal to Pg1 lesser than or equal to 600 megawatt. For first generator, if you on means 100 megawatt minimum has to be supplied. It can go for up to maximum 600 megawatt. Second generator is giving minimum of 75 megawatts and maximum of 800 megawatts is given. So how do we commit the unit for the load 600 megawatt? So we need to see, for a 600 megawatt is there, how to go. Either we have to go with the first unit only, or second generator only, or combination of both, that is economic dispatch of the both unit, that we will see. For a demand of 600 megawatt, the things is given here. So you can see here, the table 4.1, you can just clearly see unit 1, 2 conditions, and what is the power generated by the two generators. Pg1 is from the first unit, Pg2 is the second unit, and fuel cost of the first generator, F2 is the fuel cost of the second generator, total cost. When both the units are at off condition 0 0, then the power generator is 0, obviously the fuel cost is 0. Now only first unit is on. Now you can see unit 1 is on, unit 2 is off. So generator is, the first unit is 600 megawatt, second unit is 0. So using the fuel cost function, F1 is given. No, if you put that Pg1 as 600, you will get the cost. Dollar is $5,440. So second unit no generation, so total cost is 5,440. Or if only second unit is on, you can see here, first unit is off, second unit is on. First unit generation is 0, second unit generation is 600. Obviously first unit cost is less. Second unit cost, F2 equation, if you put Pg2 as 600, you will get 5060. And the next condition is both the units are on and working on economic dispatch. Unit 1 is on, unit 2 is also on. Pg1 is 233.33 and Pg2 is 366.67. This is the unit economic dispatch. Okay, so F1 cost is 2017 rupees and F2 cost is 3115. Addition of these two, you will get the 5133. So by seeing this, for 600 megawatt, which is good. If two units are not there, there is not possible. Only first unit is on, it is giving a cost of 5440. Second unit is only on, it will give amount of 5060. And both the units are working, then it is giving you 5133 rupees. By seeing this, only second unit if you are using, so that is the fuel cost is cheaper. So we will go for 600 megawatt. Only second unit to be used. For the same condition, if you go for this 800 megawatt, what happens? Only first two units, it is not possible. Only unit 1 is it is infeasible, because it is 800 megawatt. If first unit is having its demand or its capacity is only 600 megawatt. So first two condition, it is not possible. Only unit 2, okay, unit 2 is possible because it is 800 megawatt is a maximum. If it is 800 megawatt, its cost is F2 6900. But if it is both the units are working in economic dispatch, first unit gives 300 megawatt, second unit gives the 500 megawatt. Total two costs are 2560 and 4200. The total cost is 6760. So here, for 800 megawatt demand, two units should be worked at the economic dispatch. You can see in the previous step, only second unit was enough for 600 megawatt and it was the economic. Here unit commitment is two units should be on, because it is gives 6760 instead of only second unit will use the 6900. So you understood now when the unit should be on and when the unit should be off. The same thing for 400 megawatt to 1200 megawatt variation from the 100 megawatt. You can see for 400 megawatt only second unit is enough. For 500 megawatt only second unit is enough. 600 megawatt is also second unit is enough. From 700 onwards, both the units should be work under the economic dispatch. Means The unit commitment is what? After 600 megawatt, second unit, first generator unit should be committed to on. So the shutdown rule is very simple. If 700 megawatt, the 700 megawatt is there or above the demand is there, both the units should commit. If it goes below the 600 megawatt, commit only unit 2. So this is what the unit commitment problem. So in the next class we will see that what are the different constraints of unit commitment. What is the unit commitment, you come to know now. Now what are the different constraints is there in the unit commitment, we will see it in the next class. Thank you.